Hey Jams of ExamsNet, welcome to the question series of ExamsNet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for the better preparation of your exams. So today, students, we will be solving TSM set, that is Telangana State Engineering, Agriculture and Medical Combined Entrance Test, 14th May 2023, Shift 1 question paper. Okay, in this particular video, I'll be solving the physics part of the paper. So here we go. So, starting from the very first question of this physics series, that is question number 81. So, the question says that the ratio of the relative strength of strong and weak nuclear forces is. Okay. So, this question is from the chapter of physical world. Okay. Physical world. As we know that there are four fundamental forces in the nature. Okay. There are four fundamental forces. The first one is strong nuclear force, and the second one is electromagnetic force, The third one is weak nuclear force, and the fourth one is gravitational force. Okay, these are the four fundamental forces in the nature. The strong nuclear force, this acts between the two nuclei. This force holds the two nuclei together. Okay, the electromagnetic force, it acts between the matter, means it generally uh, uh, acts for holding the matter together. And the weak nuclear forces acts between elementary particles. For example, for radioactive decay, weak nuclear force acts for the nuclear active decay type of processes. And the gravitational force, this force acts between massive bodies like sun and between the planets. Okay, so in this question, we are asked to find the ratio of the relative strength of the strong and the weak nuclear force. Okay, so students, strong nuclear force is the force that acts inside the nucleus. Okay, between nucleons of an atoms. Let us say this is nucleus, and inside the nucleus there are nucleons. So sorry, there are nucleons, neutrons, protons. So these strong nuclear force acts between two protons, two neutrons, between neutrons and proton pair. So it is the strongest force in the nature. Weak nuclear force is responsible for changing of the neutron to proton, vice versa, means for the elementary particle. For example, we will write a very basic equation for a nuclear force, like neutron changes into proton plus electron plus one anti-neutrino. Okay, this is the simple radioactive decay process, means a neutron is converting decays into a proton plus an electron plus one anti-neutrino. Okay, this is an example of beta decay. Okay, so it is not very strong as compared to strong nuclear force or the any other forces. So the ratio of the strong and the nuclear forces relative strength is 10 to the power 13. Okay, so the option A is the correct answer. Okay, now next question 82. The number of significant figures in the measurement of a length of 0.079000 meter is. Okay, so this question is from the chapter of units and measurements. Okay, we have to find the least significant figure, and the figure we are given as 0.079000. Okay, so the significant figure, we know that it is a measured value of digits which are accurate only. Okay, we call them significant figures. We There are some rules for counting the significant figures. I hope you all know those rules. So let us recall those rules. Okay, the first rule is that all the non-zero digits are significant. All the non-zero digits are significant, means like this, in this figure, those digits that are non-zero are considered as the significant figures. And the second rule is that zero placed left of a digit are never significant. Whenever zero comes in left to a significant figure, for example, let us say this is 1. If a zero is coming in the left of a significant figure, so we not consider this zero as a significant figure. Okay. And the third rule is that zero placed after a digit is a significant figure. For example, let us say 010. So this left zero is not significant, but this zero which is coming right to a significant figure, it is a significant figure. Okay. And the fourth rule is that zero placed after a digit is significant, and the decimal, if we put a decimal here and then we consider these zeros, so we will consider these also as a significant figure. Okay. So in this given question, the significant figures are, according to these rules, this zero, these two zeros, these come in front of the, means left to the significant figure, so these two will not be considered as the significant figures, but these three zeros that are coming right to the significant figure, so these will be considered as the significant ones. So total significant figure will be 1, 2, 3, 4, 5. So option C, that is 5, is the correct answer. Okay. Now next question, 83. The acceleration of a vertically projected body at its highest reaching position is, okay. So this question is from the chapter of motion in a straight line. Okay. Motion in a straight line. And we have to find the acceleration. Okay. So given that the motion of the body is in the vertical direction. Okay. So let us say there is a body which is thrown vertically. Let us say there is a body and it is thrown vertically upward with initial velocity is u. Let us say here the point is A and it is point B, and a body is thrown from point A to point B and its initial velocity is given as u. Okay. At the height point B, the final velocity will become 0. Okay. So let us say this height is h. Okay. This u is the initial velocity and the final velocity v will be 0 and h is the height. So force acting at a point B is given by, at point B, the force will be given by F is equals to mass into acceleration. Let us say this is equation number 1. Okay. So we know that equation of motion V is equals to minus u plus zt. Okay, from the very first equation of motion, V plus u equals to at na. So we can write V equals to minus u plus of, in place of this a, we can write gravitational gt. Okay. So okay, and here in this law of motion, okay, in this equation of motion, so the direction of u and g is opposite. Okay, u and g are opposite, so we can write u is equals to gt as the final velocity is 0. Okay, let us say this is equation number 2. So multiplying the mass on both sides, let us say this will be mu is equals to m into g into t. And we know that momentum p is equals to what? Mass into velocity. Here the velocity is u. So in place of m into u, sorry, we can write p is equals to mgt. So we can write p over t equals to m into g. Okay, let us say this is equation number 3. Okay, if we compare this equation 1, that is F equals to mass into acceleration, with equation 3, that is P by T equals to M into G. So we know, we came to know that this A is equals to G. So the acceleration at the highest point where the velocity V is equals to 0, it is equals to the acceleration due to gravity at that place. Got it? From equation 1 and 3. First equation says that F equals to mass into acceleration. Third equation says that P over T. P over T is what? Nothing but force only. Okay. It is equals to M into G. So if we compare these two equations, we get acceleration is equals to Z. So at the highest point, means at point B, where the velocity V becomes 0, at that time, the acceleration A is equals to the acceleration due to gravity G. Okay. So from this, The option B, that is the acceleration equals to the acceleration due to gravity at that place, is the correct answer. Okay. Now next question, 84. A player can throw a ball to a maximum horizontal distance of 80 meter. If he throws the ball vertically with the same velocity, then the maximum height reached by the ball is. Okay. So this question is from the chapter of motion in a plane. Motion in a plane. We have to find the maximum height reached by the ball. Okay. So given the horizontal range, means horizontal distance. The horizontal range is given as r equals to what? 80 meter. And we are given if it throws the ball vertically with the same velocity. Okay. For a horizontal distance, we know that the angle theta is what? 45 degree. Okay. So as the angle of projection is 45 degrees, so the range of the projectile will be maximum. So using the formula, the range formula is what? R is equals to u square sine 2 theta over g. This is the formula for the range. Okay. This we already know from the chapter of projectile motion, that is R is equals to u square sine 2 theta over g. So R is what? 80 meters. So 80 into this G gravity 10 is equals to U square sine 2 theta. 2 means 2 into 45 degree. So this 800 will be equals to U square sine 90 is what? 1. So we can write U square is equals to 800. Okay. Let us say this is equation number 1. Okay. Now using third equation of motion for vertical motion. What is third equation of motion? V square is equals to U square minus 2as for a vertical motion, let us say. Means if this is a projectile motion, for this vertical motion, if we are using third equation of motion, means v square equals to u square minus 2as, where u and this gravity g are in opposite direction. Okay. Opposite in nature. Okay. So at the highest point, we know that at highest point the velocity v becomes 0. So for this we write u square equals to 2gs. Okay. So from here we can write s is equals to u square over 2g. Okay. And where s is the height from the horizontal level. So from this we can write s is equals to u square. From equation 1, u square is what? 800 over 2 into g. Gravity is 10. So it will be equals to 240. So s is equals to 40 meter. So in this question, we are asked to find the maximum height. Na? So maximum height as is equals to 40 meter. That is option D is the correct answer. Now next question, 85. If a man of mass 50 kg is in a lift moving down with an acceleration equal to the acceleration due to gravity. Okay, it is moving down with the acceleration which is equals to the acceleration due to gravity. Then the apparent weight of the man is. Okay. So this question is again from the chapter of motion in a plane. Motion in a plane. Okay. So from the question, we are given mass of the man equals to what? 50 kg. And acceleration due to gravity, g, we know that 10 meter per second square. Okay. Let us say this is the lift and the mass means the man is going downward. And for this, the acceleration given as g. Okay. So net acceleration in the case of this lift will be equals to A net will be equals to gravitational G minus the acceleration A. Let us say this is one where this acceleration A is the acceleration of the lift. Okay. Acceleration of the lift. So net acceleration will be the downward gravity minus this acceleration of the lift. So A net will be equals to, according to question, this A is also equals to G. So G minus G. So net acceleration will be equals to 0. So the apparent weight in this case will be, W equals to mass into net acceleration. Okay. And net acceleration is what? 0. the weight will be 0. So apparent weight in this case, when the lift is going in the downward direction and the acceleration means acceleration of the lift becomes equal to the gravity g, in this case the acceleration, apparent weight of the man will become 0, means options A is the correct answer. Okay. Now next question 86. An engine is dragging a mass of 5,000 kilogram with a velocity of 5 meter per second along a smooth inclined plane of inclination 1. Inclination is 1 by 50. Okay. Okay. Then the power of the engine is, okay. So this question is from the chapter of laws of motion. Laws of motion. Okay. Now we are given an inclined plane. Let us say this is an inclined plane, and according to question, an engine is dragging a mass of this. Let us say this is the mass and this is of 5,000 kg, okay, along a smooth inclined plane with a velocity is given as 5 meter per second. So the downward force will be mass into gravity g, and here we will write mg sine theta, frictional force na, mu equals to mg sine theta. Let us say this angle is theta, so we write mu equals to mg sine theta and downward force is mg. So we have to find the power of the engine. Okay, we are given with mass equals to 5,000 kg. Okay, velocity what? 5 meter per second, and inclination is 1 by 50. Inclination is given as 1 by 50. So if theta, this theta is the angle of inclination, so we can write sine theta is equals to 1 by 50. Okay. So force acting on the mass on inclined plane, net force will be equals to this mg sine theta plus the frictional force. Frictional force. Okay. So in this case, when the smooth inclined plane, in this question, we are given a smooth inclined plane. So smooth inclined planes, this frictional force will be 0. Okay, there will be no frictional force. So the net force will be equals to this mg sine theta. Okay. So it will be equals to m, 5,000 into gravity 10 into sine theta 1 by 50. So solving it, we get force, net force will be equals to 1000 Newton. Okay. So power will be equals to this force into velocity. Force is 1000, velocity is 5 meter per second. So it will be 5,000 watt. Okay. Means 5 kilowatt. So our correct answer is option A, 5 kilowatt. Now next question 87. A ball falls freely from a height h on a rigid horizontal plane. If the coefficient of restitution is e, then the total distance traveled by the ball before hitting the plane second time is, okay. So this question is given from the chapter of work, energy and power. Okay. So in this question, given height h is equals to, okay, height is given as h. Okay. Height is given as h only. Coefficient of restitution. Restitution is what? E. Okay. And we are given the ball reaches, okay, ball before hitting the plane second time. Okay. So U will be under root of 2gh, means when the ball is dropped from the height, let us say its initial velocity u is equals to under root of 2gh when it dropped from a height of h. Okay, let us say, let us understand is like this. Let us say suppose this is of height h. Okay, and a ball is dropping like this. Okay, so first time its height will be h, and when it hits second time, let us say its height will be h1. Okay, so if the collision on the force is elastic, let us say, the ball will rebound like this with the same velocity, but the coefficient of restitution is A and the velocity V will be less than this velocity U. So we write here the V will be E into U. Okay. This V is the velocity of separation and here U is the velocity of approach. Okay. This U is the velocity of approach and this velocity is the velocity of separation. So in the above case, so now the height will become h1. So for this we can write h1 is equals to v square over 2g. And since v is equals to e into u, so h1 will be equals to e square into u square over 2g. So since the initial height is h is what? U square over 2g. So putting this value in second condition, so we get h1 is equals to, means in this condition, in place of u square over 2g, we can write h. So we get h1 is equals to e square into h. So the total distance traveled by the ball before hitting the place second time will be, distance will be equals to this h plus e square h plus e square h. So it will be equals to h plus 2e square h. Taking h common, we get 1 plus 2 is e square. Got it? This is our final answer. Means the option B, that is h1 plus 2e square, is the correct answer. Now next question. The velocity of a particle having magnitude of 10 meter per second in the direction of 60 degree with the positive x-axis is, okay. So this question is from the chapter of system of particles. System of particles, okay. We are given what? Velocity of particle of magnitude 10 meter per second, means velocity is 10 meter per second along the x-axis. Let us draw it like this. Let us say this is x-axis, this is y-axis, and this is the particle whose velocity is 10 meter per second and the angle is of 60 degree. Okay. So the component of the velocity along x-axis will be v cos theta iota cap. Okay. And along y-axis it will be v sin theta jth cap. Okay. So the v will be equals to algebraic sum of both vx iota cap plus vy jth cap. So it will be equals to v cos theta iota cap plus v sin theta j cap. Okay. Velocity is what? 10 meter per second and theta is 60 degree. So just put the value 10 into cos 60 into iota cap plus 10 into sin 60 into j cap. So it will be 10 into 1 by 2 cos 60 to 1 by 2 iota cap plus 10 sin 60 is root 3 by 2 j cap. So it will be equals to 5 to 5 is 10. So 5 iota cap plus 5 root 3 j cap. Okay, this is our final answer. So we will be 5 iota cap plus 5 root 3 j cap, means option D is the correct answer. Okay. Now next question 89. The ratio of the radii of two solid spheres of same masses is 2:3. Okay. The ratio of the moments of inertia of the spheres about their diameter is, okay. So in this question, we have to find the ratio of the moment of inertia. So first of all, we are given what? Ratio of the radii of two spheres, means we are given R1 over R2, means 2 by 3. Let us say this is equation 1. Since both are the solid spheres, so masses will be same. Masses will be same na, for both the solid sphere. And moment of inertia for the solid sphere, we know that I is equals to 2 by 5 mr square. Okay. Let us say for sphere 1. For sphere 1, let us say its radius will be capital R is equals to R1. So moment of inertia will be equals to, for first one, 2 by 5 m1 into r1 square. Let us say this is equation second. Okay. Now, for spare 2, let us say its r will be r2. So moment of inertia of second spare will be equals to 2 by 5 m2 into r2 square. Let us say this is equation 3. Okay. So dividing the equation second by 3. So moment of inertia of the first one to the moment of inertia of the second one, it will be equals to 2 by 5 m1 r1 square over 2 by 5 m2 r2 square. Since the masses are same, so m1 m2 cancels. This 2 by 5 cancels. So we get moment of inertia of the first one to that of the second one will be equals to r1 over r2 whole square. And we are given r1 over r2 as 2 by 3. Na? So just put the value. So it will be equals to 2 by 3 whole square means 4 over 9. So the ratio is 4:9. So among these four option A is the correct answer. Now next question 90. The displacement of a particle executing simple harmonic motion is given by x equals to 2 cos t, where t is the time in the seconds, then the time period of the particle is. Okay. So this question is from the chapter of oscillations. Okay. Okay. So we are given what? Displacement x equals to 2 cos t. Let us say this is equation number 1. So comparing it with the standard displacement of simple harmonic motion. What is the standard displacement? X equals to a cos kx plus omega t. This is a standard value for the displacement of a simple harmonic motion. So comparing with it, we get a is equals to 2. Okay. K is 0 and omega equals to 1. Where omega is what? Angular frequency. Okay. So we know that omega is what? 2 pi f. F means 1 by t. So it will be 2 pi over t, where t is what? Time period. So time period t will be equals to 2 pi over omega. And we are given omega as 1. So put the value of omega as 1. So t is equals to 2 pi second. So the correct answer is option B, that is 2 pi second. So question number 91. This question says that a man weighing 75 kg is standing in a lift. The weight of the man is standing on a weighing machine kept in the lift when the lift is moving downwards freely under gravity is. Okay. So this question is from the chapter of gravitation. So first of all, the man is himself is standing on in a lift. At that time, the weight of the man is 75 kg as given in the question. So after some time, a weighing machine is kept in the lift and the man is standing over this weighing machine. Okay. So we have to find the weight of the man when he is standing on this weighing machine, which is kept in the lift, and the lift is going in the downward direction freely under gravity. Okay, so we have to find the weight of this man. So first of all, in this the weight is given as 75 kg. So lift is going in the downward direction. Okay, when the lift is going in downward direction, the acceleration is equals to gravity, so it is equals to 10 meter per second square. Okay, so the net acceleration of the lift, will be equals to what? A net is equals to gravity minus A acceleration. So let us say this is equation number 1 and this A is the acceleration of the lift. Okay. This is the net acceleration of the lift which is going in the downward direction. This will be equals to gravity minus the acceleration of the lift. Okay. So A net will be equals to this gravity, and this A is equals to G, means it will be equals to G. So G minus G will be equals to 0. So the weight inside it means the weight of the man when the lift is going in the downward direction will be equals to weight equals to mass into a net means acceleration of the lift. So it will be equals to 0 as a net is equals to 0. So the weight of the man which is standing on this weighing machine which is going in the downward direction will be equals to 0. Hence, the correct option is option A. Now, next question is 92. The dimensions of four wires of same material are given below. The increase in length is maximum in the wire of. Okay, we have to find the maximum increase in length. So, for such type of question, first of all, we know that the Young's modulus Y is equals to stress over strain. Okay, stress over strain. So it is equals to force over area into original length into elongation in length means increase in length. So for this increase in length, delta L will be equals to F over A into this L over Y Young's modulus. Okay. And here we are given in all the four options, we are given with the diameter. Since we know that area is what? Pi r square. But we have to write it in terms of diameter. So we write pi d by 2 whole square. Okay. So in place of A, we can write del L will be equals to F over pi d square into 4 into L over Young's modulus Y. This 4 is constant since these four wires are of same material. So F will be constant, Y will be constant, and pi is constant. So we write del L equals to L over D square. Okay. So using this equation for all the four wires. So for A wire, length is 100 centimeter and diameter is 1 millimeter. 1 millimeter means 10 to the power minus 1 centimeter. Okay. So for this del L will be equals to 100 over 10 to the power minus 1 whole square. Okay. So it will be equals to 100 into 10 to the power plus 2. So it will be equals to this k. Okay. In terms of for f, pi and y, write k. K is the constant term. Okay. So for B case, L is given as 202 millimeter, 200 centimeter, and D is given as 2 millimeter. Okay. So it will be del L will be equals to 200 K over 2 into 10 to the power minus 2 whole square. So it will be equals to 200 over 4 into 10 to the power minus 4. So it will be equals to 50 into 10 to the power plus 4 K. Okay. And for C case, L is equals to 303. L is equals to 300 centimeter and D is 3 millimeter. Okay. So solving it, we get delta L is equals to 300 over 3 into 10 to the power minus, oh sorry, it is 1, na? 10 to the power minus 1, not 2. So it will be 10 to the power minus 2 only. So it will be 10 to the power plus 2 only. Okay. Here also, okay, correct. So 10 to the power minus 1 whole square. So it will be 300 over 9 into 10 to the power minus 2. So it will be equals to this 33.3 into 10 to the power plus 2. Okay. This into K. Now D option, L is equals to what? 50 centimeter and 0.5 millimeter. L is equals to 50 centimeter and D is equals to 0.5 millimeter. So solving it, we get del L equals to 50 over 0.5 into 10 to the power minus 1 whole square. 0.5 means 50 over 1 by 2 whole square. 1 by 2 means 1 into 4 over 10 to the power minus 2. So solving it, we get 200 into 10 to the power plus of 2k. So among these four answers, so option D is the correct option. That is length 50 centimeter and diameter 0.5 millimeter. Okay. Now next question 93. A cylindrical vessel open at top contains 50 liters of water. Water drains out through a small opening at bottom. 5 liter of water comes out in time T1. The next 5 liter in further T2 and the last 5 liter in further T3. Then we have to find the correct answer among these four options. Okay. So first of all, this question is from the chapter of mechanical properties of liquid. Okay. Mechanical properties of fluids. So now we are given the total volume is what? Total volume of the vessel is 15 liter. Okay. 5 liter water is in time T1 according to question. The next 5 liter is in time T2 and the another 5 liter is in time T3 as given in the question. Okay. So let us say the question is like this. This is the open top and this is the outlet part. Okay, out part. Okay, so velocity of the flux is given by, we know that velocity of flux is given by under root of 2gh. Okay, so this velocity comes out from the third equation of motion, that is v square equals to u square minus 2as. Since here as displacement is in terms of height, gravity in terms of acceleration, and u is the initial velocity, means this is considered to be zero. So this v square is equals to what? Under root of v square is equals to uh under root, sorry, 2gs na, in terms of s we write h, so v will be equals to under root of 2gh. Okay, so the velocity of the flux, we considered it as under root of 2gh. Now for the first 5 liter, initial height is h1. For first 5 liter, the initial height is h1. Let us say the initial height is h1 for the first 5 liter. The next 5 liter, the initial height will be h2, and the next 5 liter, the height will be h3. Okay. Since if we see from this figure, the h1 height will be greater for than h2 height, and it will be greater than the h3 height. Okay, so therefore this h is directly proportional to velocity. So velocity of v1 will be greater than v2, it will be greater than v3. So as the water flows out, the height of the water level also decreases. That's why h1 is greater than h2 and h2 is greater than h3. This results in a decrease in the water flow, that is, the rate of level decreases with time. So the rate of level decreases with time means T1 is less than T2 is less than T3. Okay. So the correct answer is option A, that is T1 is less than T2 less than T3. Now next question 94. A cylinder of mass m and material density rho hanging from a string is lowered into a vessel of cross-sectional area capital A containing a liquid of density sigma, which is less than rho, until it is fully immersed. The increase in pressure at the bottom of the vessel is okay. So this question is again from the chapter of mechanical properties of fluids. So in this question, we are given with a cylinder whose mass is m. So mass of the cylinder, first of all, is given as small m, and density of that cylinder is given as rho, and cross-sectional area is given as A of that vessel. Okay. So density of the liquid which is filled in that cylinder is what? Sigma. And given that this sigma is less than rho until it is fully immersed. Okay. So the increase in pressure delta P will be equals to change in the force over area, increase in pressure. So since this delta F is what? Buoyant force na, for the for such type of liquid density questions, the change in the force will be equals to what? Buoyant force. Buoyant force. Okay, so it will be equals to v velocity into gravity into sigma. So writing this in place of force, we can write Acha, okay. For at first, this V volume, this volume of the cylinder is what? Mass over density. So delta P can be written as, in place of this volume, we write mass over this density. So we can write delta P, change in pressure, as mass over density into sigma into gravity. Okay. Over this area A. Okay. Now, so delta P will be equals to M into sigma into G over rho into area. So this is our final answer. So option D, that is M sigma G over rho A, is the correct answer. Now next question 95. The Fahrenheit and Kelvin scales of temperature will have the same reading at the temperature of. Okay. The Kelvin scales and Fahrenheit scales must be same for a temperature, and we have to find that temperature. So this question is from the chapter of thermal properties of matter. Thermal properties of matter. Now let let us say that temperature be X. Let that temperature be X. Okay. So according to question, the Fahrenheit and the Kelvin scales must be same for that temperature X. Okay. So F is the temperature in Fahrenheit and K is the temperature in Kelvin. We know the relation between Fahrenheit and Kelvin is what? F minus 32 over 9 is equals to what? K minus 273 over 5. So put X in place of F and K, since F and K are equal to X according to question. So X minus 32 over 9 is equals to X minus 273 over 5. So solving it, we get 5X minus 160 is equals to 9X minus 7 carry 2, 65, 6, 18 and 6, 24 over, this is 9X, okay? So solving it, we get 4X minus 2457 plus 160 will be equals to 0, okay? So for this, we get X is equals to 574.6, means that temperature when the Fahrenheit and Kelvin scales are equal, that temperature is 574.6 degree Fahrenheit. Okay, or we can say 574.6 degree Kelvin. Only Kelvin. Okay. Now next question 96. If the ratio of densities of two substances is 5:6 and the ratio of their specific heat capacities is 3:5, then the ratio of heat energy is required per unit volume so that the two substances can have same temperature rise is. Okay. So this question is from the chapter of thermodynamics. Okay. This question is from the chapter of thermodynamics. We are given the ratio of two substances. Ratio of density of two substances means we are given rho1 over rho2 as 5/6, and we are given ratio of the capacities means C1 over C2 as 3/5. Okay. So we will use here the formula for the heat, that is delta Q is equals to MC delta T, the general formula for the change in the heat. Delta Q is equals to MC delta T, where delta T is the change in the temperature. Okay. So for, let us say, first substance, this delta Q1 will be equals to M1 C1 delta T1. Okay, let us say this is equation number 1. And for second substance, this delta Q2 will be equals to M2 C2 and delta T2. Let us say this is equation number 2. Okay. Now divide equation 1 by second. So equation 1 over equation 2. So it will be equals to delta Q1 over delta Q2 will be equals to M1 C1 delta T1 over M2 C2 delta T2. Okay, since we are given that the temperatures are same, temperature rise are same, so delta T1 cut delta T2, so it will be equals to M1 C1 over M2 C2. Okay. So from here we get delta Q1 over delta Q2 is equals to what? Since we know that mass is equals to what? Volume into density. Okay. So in place of mass, we can write V1 into rho 1 into C1 over V2 into rho 2 into C2. Okay. And we know that the ratio of densities is 5:6 and capacities is 3:5. So just put the value. So delta Q1 over this V1 over delta Q2 over this V2 will be equals to what? Rho 1 into C1 over rho 2 into C2. So just put the values 5/6 into 3/5. Okay. So this 5 cancels, 3 2s are 6. So this delta Q1 over V1 over delta Q2 over V2 is equals to 1/2, means the ratio of the heat energy required per volume so that the two substances have same temperature is 1/2, or we can say that 1:2. So the correct answer is option C, that is 1:2. Now next question 97. In a process, the work done by the system is equal to the decrease in its initial energy. The process that the system undergoes is okay. Again, this question is from the chapter of thermodynamics. Now, in this question, work done by the system is decrease in the internal energy. Work done is equals to decrease in internal energy, na? According to question. Okay. So from the first law of thermodynamics, we know that del Q is equals to del U plus del W. And here, according to question, dW is equals to, means del W equals to minus of del U. So this dQ will be equals to du plus dW. So in place of dW, just write minus of du. So this will be du minus of du. So dQ is equals to, this du is equals to 0. So the process in which dQ is 0 is called the what? Adiabatic process. So option B is the correct answer. Now 98. N molecules each of mass m of gas A and 2n molecules each of mass 2m of gas B. Okay, are contained in a vessel which is maintained at a temperature T. The mean square velocity of molecules of gas B is denoted by V2 square, and the mean square of X component velocity of the molecules of gas is denoted by V1 square. Okay, we have to find the ratio of V1 over V2. So this question is from the chapter of kinetic theory. Kinetic theory, okay. So in this question, the mass of A is given as small m and the number of molecules are n, okay. And mean square component of velocity of A gas is V1 square. So mass of B is 2m, number of molecules is 2n, and it is mean square velocity of B is V2 square, okay. So mean square velocity is given by, we know that V is equals to under root 3 kbt by m. So from here we can write V square is equals to 3 kbt over m. This is a general formula, na? The root mean square velocity. So for this, we can write VA square is equals to what? 3 kbt over m VA square, na? And VB square is what? 3 kbt over 2m. Since A having mass m, B having mass 2m. Okay. So for the gas molecule A, so V square will be equals to Vx square plus Vy square plus Vz square. So it will be equals to, since according to question, Vx equals to Vy equals to Vz, so we write it as 3 Vx square. So Vx square is equals to V square over 3. So this V1 square is equals to, let us say VA square is V1 square and VB square is V2 square. So V1 square is what? 3 kbt over 3m. So it will be, yeah, it will be equal to 3 kbt by m. Okay. Let us say this is equation number 1. Now, this V1 is square over V2 square similarly will be equals to kbt over m into 2m over 3 kbt. Okay, so solving it, we get kbt cancels, m cancels, we get 2 by 3. So the ratio is V1 over V2 is equals to under root of 2 by 3. This is our final answer. Okay, so option D is the correct answer. Now, next question 99. Among the following statements, the correct statement for a wave is. So, this is from the chapter of waves directly. We have to find the correct option. Okay. In option 1, the transverse waves cannot propagate through all the media. It is wrong statement. And the option B, longitudinal waves can propagate through solid only. It is also long statement. The transfer waves can propagate through solid. Okay, the transfer waves, first of all, let us know what are transverse waves now. So transfer waves are those waves whose vibration is perpendicular to the direction of propagation. Okay, these are perpendicular to the direction of propagation. And what about longitudinal waves? So longitudinal waves are those waves whose vibration of medium is parallel to the direction of propagation. Means for transfer, these are perpendicular, and for longitudinal, these are parallel. Okay, so it can propagate in all mediums, solid, liquid, and gas. No mechanical waves can propagate through any without any medium. So option C is the correct answer. Means they can travel through solid as well. They can travel through all media. Means they can travel through solid also, they can travel through liquid or gas also. Okay, so option C is the correct. And in the same way, option D is the incorrect one, that is longitudinal waves can propagate through vacuum. Okay, so next question 100. A source and an observer move away from each other with same velocity 10 meter per second with respect to ground. The observer finds the velocity of sound coming from the source as 1980 hertz. The actual frequency of the source is. Okay, so this question is from the topic of Doppler's effect. Okay, this is from Doppler's effect topic, means from the chapter of relativity only. So observer velocity is given as V naught. It is given as 10 meter per second. Okay, and source velocity Vs will be, because of this, it will be minus 10 meter per second. Okay, and source frequency is f dash is given as 1980 hertz, and speed of sound v is given as what, 340 meter per second. Okay, so according to Doppler's effect, the frequency f dash is equals to f v minus v naught over v minus this vs. Okay, means the frequency will be equals to f into v. V means this speed of sound minus this observer velocity over speed of sound minus source velocity. Okay, so this f dash is given as 1980. It is equals to f, which we have to find the actual frequency, over 340 minus 10 over 340 minus of 10 means plus 10. Okay, so f will be equals to 1980 into 340 plus 10 into 350 over 340 minus 10 means 330. So solving it, we get f is equals to 2100 hertz. So 2100 means option B is the correct answer. Now, next question is 101. Convex lenses of focal length 20 centimeter and 30 centimeter are placed in contact with each other coaxially. The focal length of the combination is. Okay, so this question is from the chapter of ray optics. So in this question, we are given with two convex lenses. The first focal length is f1 is equals to 20 centimeter and f2 is given as 30 centimeter, okay? And the focal length is positive for convex lens, na? So the focal length of the combination will be 1 over f will be equals to 1 over f1 plus 1 over f2. So it will be equals to 1 over 20 plus 1 over 30. So solving it, we get 3 plus 2 over 60 equals to 1 over 12 centimeter. So the focal length of the combination is 12 centimeter. So the correct answer is option C. Now next question 102. A point source of light is placed at the focus of a concave mirror. Okay. Consider only paraxial rays. The shapes of the wavefronts of incident and reflected lights respectively are. Okay. So we are given with a concave mirror. So again, this question is from the chapter of ray optics only. We are given with a concave mirror. Na? So let us say this is a concave mirror. Okay. And the point source emits the spherical wavefronts as the light diverges from a point source in all direction. Okay. So here incident wavefront will be spherical in nature as given in the question. So when the rays got reflected by the concave mirror, the reflected wavefront will be planed. Okay. Planar. So let us say the light rays are coming from this direction. So, sorry, light rays are coming like this. Like it will be going through this point, again like this, and again like this, and again like this. Okay. So according to question as given in the question, these are forming the spherical wavefronts. Okay. Spherical wavefront, and as they are reflected, though they are forming a reflected wave planar wavefront. Okay. Reflected wave planar wave front. Okay, so when the light rays goes reflected by the concave mirror, the reflected wave will be planar in nature. So option B, that is spherical and planar in nature, is the correct answer. Okay. Now next question. If the electric potential at a point on the surface of a hollow conducting sphere of radius r is V, then the electric potential at the point which is at distance r by 3 from the center of the sphere is. Okay. We know that since it is from the question of electric charges and field, electric charges and fields. Okay. So first of all, it is the question is asking about the hollow conducting sphere. Hollow conducting sphere means the electric field inside the sphere is zero and all the charges resides only on the surface of the sphere. Okay. All the charges resides only on the surface of the sphere. So the radius of this sphere is given as r. Okay. So, and according to question, the electric potential at the surface when V R is equals to R, it is given as capital V, and the electric potential when R is given as R by 3. So at that time, the potential V R equals to R by 3, we have to find this value. Okay. So as we know, the charges resides only on the surface of the sphere. So electric field inside this sphere is 0. So using the relation, electric field is what? Minus del V over del X. Okay. Since electric field is 0, so it will be equals to minus of del V, means the V is constant inside the sphere and it is equal to the value of potential on the surface of the sphere. So since E is 0, so V will be constant. Okay, so V will be constant. So the potential, um, so the potential at R equals to R by 3 is also V. Okay, so the correct answer is option A. Now next question 104. The effective capacitance between points A and B shown in the circuit. Okay. So here the circuit is not visible. Yeah, now it is visible. So we have to find the effective capacitance between this point A and this point B. Okay. So again, this question is from the chapter of electric charges and fields. Okay. Now, since each capacitor has a capacitance of C, so this circuit can be simplified as like this. Let us say this is point A. Okay, this is C and C, na, so we can draw it like this. Like this is C and this is another capacitance C and C. Let us say this is 1. Okay. Now this combination, this is again C, C, so we can draw it as, let us say this is C capacitor. This is another capacitor C. Let us say this is numbering as 2. And this is point B. And now this capacitance is between A and B, na? So we can draw it like this. Okay. This is C. Okay. So from 1 means from this. So we can write it C equivalent as, since these are in parallel. So for parallel combination, the capacitance are the algebraic sum. So C1 plus C2 means this C plus this C. So it will be equals to 2C. Okay. Let us say this is equation number 1. Okay. And for second also, this will be C equivalent will be C1 plus C2 means 2C. Here also 2C, na? Okay. Since now this C, this is 2C, this is 2C, and this is C. So these are connected in. So this will, okay. First of all, these are in parallel, they are making 2C. These two are in parallel, they are making 2C. So this circuit can be redrawn as, let us say this is A. This is the C equivalent of these 1. This is the C equivalent of second. And now this is point B. And this is C. Okay. So now the C equivalent for this combination will be, for these two, since these two are in series, so for these two we can write 1 over C1 plus 1 over C2 means 1 over 2C plus 1 over 2C. Since for this also this is 2C and for this also this is 2C. So these will be in the form of series combination, and for series combination we write 1 over 2C plus 1 over 2C. So solving it we get C equivalent is equals to C. Okay. Now the net capacitance will be for these two capacitor having capacitance 2C and 2C, we find their series combination as C. Now this C and this C, these are in parallel. So so net capacitance will be C plus C for parallel combination, and it will be 2C. This is our final answer. So the correct option is option A. Okay. Now next question 105. The Wheatstone bridge shown in the diagram is balanced if P3 is the power dissipated by R3, okay, and P1 is the power dissipated by R1, then we have to find the ratio of P3 over P1, okay. So this question is from the chapter of current electricity, okay. Now, Wheatstone bridge is balanced according to the question. So for R3, the power dissipated is P3, and for R1 it is P1. Okay. Since the Wheatstone bridge is balanced, so no current will flow from the galvanometer arm. Okay. So from the balancing condition of the Wheatstone bridge, we know that the balancing condition of Wheatstone bridge is what? Wheatstone bridge. It is equals to R1 over this R3 equals to this L over K. This is the balancing condition. We all know this condition, okay? So power dissipated by the resistance circuit is given by P is equals to V into I, okay? And P is also I square into R. So for R1 and R3, we can write P3 is equals to I square into R3, and for P1 we can write I square into R1. Okay. So the ratio of power dissipated, we have to find the ratio of power dissipated, na? So P3 over P1 will be, it will be equals to I square into R3 over I square into R1. So it will be I square cancel, and R1 over R3 is what? L over K. So R3 over R1 will be K over L. So K over L is our final answer, means the correct option is option A. Now next question 106. A wire of resistance 2R is stressed such that its length is doubled. Then the increase in its resistance is, okay. Again, this question is from the chapter of current electricity. Current electricity, okay. Now, resistance of the wire is given as 2R. Resistance is given as 2R, and radius of wire is, let us say, small r, okay. Let us say uh, the radius of the wire is small r, length of the wire is, let us say, capital L, and area is A, okay. So when the length of the wire is stressed to double, then the volume will remains the same. So V initial will be equals to V final, okay. So V initial is what? Length into area will be equals to new length L dash into new area A dash. So A dash will be equals to L into A over L dash. L dash means the length is doubled. So in place of L dash, we will write 2L. So 2L, it will be equals to this A, LL cancels, A by 2. Means the new area is A by 2. Now, according to question, let us say the initial resistance is R1 equals to 2R. So it will be, we can write R as rho L by A. This is the famous relation between resistance and resistivity, that R is equals to rho L by A. So in place of R, we have written rho L by A. So now new resistance will be R2. It will be rho L dash over A dash. Okay. So we can write it as, okay, so we will write it as rho L dash is what? 2L over A dash is what? A by 2. So it will be equals to R2 will be equals to 4 rho L over A. Okay. So it will be equals to 4, and rho L by A is what? 2R. So we can write here 2R. So R2 will be equals to 8R. Now, in this question, we are asked to find the increase in the resistance, okay? Okay, here we will not have to write the 2. Since the resistance for R1, we are writing this rho L by A, okay? So no 2 here, okay? So that's why we have written, in place of rho L by A, we have written 2R. So it will be equals to 8R. So increase in resistance. Increase in resistance will be R dash, means R2 minus R1. So it will be 8R minus initial 2R. So increase in resistance will be 6R. This is our final answer. So option A is the correct answer. Okay. Now next question 107. It is found that a non-zero current element is unable to produce any magnetic field at a particular point. Then the angle between the current element and the position vector of that point with respect to the current element is, okay. So in this question, this is from the chapter of the moving charges and magnetism. Moving charges and magnetism, okay. Magnetism. Given in this question, a non-zero current element is unable to produce any magnetic field, means no magnetic field is here. So magnetic field B is equals to 0 according to question. Let us say the I be the non-zero current. I be the non-zero current. Non-zero current. And let us say, let us draw it as, let us say this is a wire element and this is angle theta between the current element and the position vector at the point. Let us say R be the position vector and I is the current that is flowing in the wire. Let us say this ds be the length element, okay, and R is the separation. So using Biot-Savart's law, using Biot-Savart's law, we can write dB as mu naught over 4 pi IDL sine theta over R square. This is the Biot-Savart law, na? So B will be equals to mu naught over 4 pi I into L sine theta into R cap over R square, where this over R square, okay? Where this L is the total length of the current carrying element. And according to question, since B is equals to 0, so for B to be 0, either the current should be 0 or this sine theta should be 0. Okay? Means according to question, we are given that there is no magnetic field. No magnetic field means this is 0. So to make this magnetic field 0, either the current should be 0 or this sine theta should be 0, okay? But in the question, it is mentioned that current is non-zero, okay? According to question, the current is not 0. So sine theta is equals to 0 and sine theta is 0 means theta is equals to 0 or pi. So this angle means this angle is between the current and the position vector must be either 0 or this pi means 180 degree, okay? So the correct answer is option B. The angle may be 0 degree or it may be 180 degree. Now next question 108. Three long straight parallel wires carrying different currents and they are arranged as shown in the diagram. In the given arrangement, let the net force per unit length on the wire C be F. Okay, C be F. If the wire B is removed without disturbing the other two wires, then the force per unit length on the wire A is. Okay. So this question is from the chapter of alternating currents. Okay. So given the force per unit length on C is F. Okay. Now let us calculate first of all the net force on C. So the net force on C will be net force force per unit length. Okay, net force per unit length will be force on CA per unit length plus force on CB per unit length. Okay, the net force on C will be force on CA per unit length plus force on CB per unit length. So F this force over L will be equals to, since it is equals to mu naught over 4 pi 2 I1 I2 over R na. So 2I into I2 over R. R means D distance. And this I1 current is I and I2 current is 2I. So for CA and CB, we will write F over L will be equals to minus mu naught over 4 pi 2 into CA means 3I and CA means 3I into 2I over D. We have written this minus sign here because in this A and C, the direction of current is in the same direction. So for same direction, we will use the negative sign, okay? So this is for CA combination, okay? So it will be equals to uh, it will be equals to mu naught over 4 pi 3 to the 6 to 12 I square over D. Okay. Now for CB combination, it will be equals to F over L. It will be equals to, sorry, this will be plus. Okay. Now it will be minus. This is they are in opposite direction. Okay. Now minus mu naught over 4 pi 2 into CB means I into 2I. I into 2I over d. So it will be equals to minus of mu naught over 4 pi 4 I square over d. Let us say this is equation 1. This is equation 2. So now if b is removed, according to question, we have to remove this wire b na. So if b is removed, first of all, we will find the net force over length for these two combinations. So it will be F net over L is equals to this equation 1 plus equation 2. So adding them, we get mu naught I square over 2 pi d, and this will be equals to force F. Okay. Now, if the B is removed, so net force on A will be F AC over L. It will be equals to minus mu naught over 4 pi into 6i into 2i over 2d. It will be equals to minus of 3 mu naught I square over 2 pi d. It will be equals to minus of 3f. So this is our final answer, minus 3f. Means option D is the correct answer. Okay. Now next question 109. If chi is the susceptibility and mu r is a relative permeability of a ferromagnetic substance, then okay. Since this question is from the chapter of magnetism and matter, and this question is asking about the ferromagnetic material. Okay. So we know that there are four different types of material. The first one is diamagnetic material. Second one is paramagnetic material. Third is ferromagnetic material. And the fourth one is anti-ferromagnetic material. Okay. So the question is about the ferromagnetic substances. So the ferromagnetic substances are those substances when they are placed in a magnetic field, they get highly magnetized. Okay. So their susceptibility of the ferromagnetic substance is much greater than 1. So option D, that is chi is very, very greater than 1 is the correct answer. Okay. Now, next question 110. The metal detector works on the principle of. Okay. So, this question is from the chapter of electromagnetic induction. Electromagnetic induction. So, metal detector. So, metal detector works on the principle of the electromagnetic induction. A metal detector produces a time varying magnetic field by the coil inside it. Okay. um, when the hidden metal is exposed to varying magnetic field, it experiences a change in the magnetic flux. Okay, the magnetic flux changes when there is a change in the magnetic field in this metal detector. Okay, so as a result, the EMF is induced, and this EMF will be equals to minus del phi over del t, because the magnetic field flux changes due to this change in the magnetic field, and due to this the EMF is induced and the eddy current is produced. Okay, so charge and motion create magnetic field. Eddy current produces its own magnetic field. This field is detected by this metal detector. So it works on the principle of the electromagnetic induction. Okay. Now next question 111. A copper disc of radius 0.1 meter rotates about an axis passing through its center and perpendicular to its plane with 10 revolutions per second in a uniform transverse magnetic field of 0.1 Tesla. The EMF induced across the radius of the disc is okay. So again, this question is from the chapter of electromagnetic induction. Electromagnetic induction. Okay. So in this question, we are given the copper disc radius. Copper disc radius as r equals to 0.1 meter, and the angular rotation n is equals to 10 revolutions per second. Okay. And the magnetic field B is given as 0.1 Tesla. Okay. So let us say a small radial position of dx element. Let us draw it as, let us say this is a small radial position dx at a distance. Let us say this is at a distance of x. From at a distance x, there is a small element dx from the center of the disk. Okay. For let us say it is moving with the angular velocity omega, angular speed, it's omega. So the velocity v will be equals to omega into x. Okay. So EMF induced across this will be equals to, let us say, DE is equals to VB into DX. This is the EMF induced, okay, in this copper disc, okay. So this EMF induced will be D equals to VB dx. So, and since V equals to omega x, so we can write dA as omega x B dx, okay. So total EMF will be E equals to, we know that the formula is half B omega R square. Okay. So using it, we write, and here omega, this omega is what? 2 pi n. So it will be 2 pi into n. N is what? 10 revolutions per second. So into 10. So it will be 20 pi. Okay. 20 pi radian per second. So putting this value, so EMF, total EMF will be equals to half into magnetic field is given as 0.1 into omega is 20 pi into R. R is what? 0.1 into 0.1. So solving it, we get EMF is equals to 10 pi into 10 to the power minus 3 volt. So E will be equals to 10 pi millivolt. This is our final answer. Okay. So among these four options, the option C, that is 10 pi millivolt, is the correct answer. Now next question 112. At very high frequencies, we have to find the current I in the given circuit. Okay, we have to find this current I in the circuit. So let us solve it as, okay, first of all, we are given some resistances, some inductance, capacitance in this circuit, and we have to find this current I. Since the frequency is very high, so inductance, capacitance will be XL, will be equals to 2 pi FL. Okay, and this will act as a open circuit. Open circuit, okay, and capacitive reactance. This is XC. XL will be equals to 2 pi FL and XC will be equals to 1 over 2 pi FC. This is the common general formula. We all know this formula, okay? And this will act as a short circuit. XL will act as a open circuit and XC will act as a short circuit. So this circuit diagram, we redraw it as this is 1 ohm and this is 4 ohm. Again, this 4 ohm and this will be 2 ohm, okay? So, and here is a potential 220 volt, okay? Alternating. So this will act like this and current I is flowing in this diagram. Since why this happened, ki XL is acting as an open circuit and XC is acting as a short circuit, because here in this question we are given the frequencies are very high. So for high frequencies, always the inductive reactance XL always act as a open circuit and capacitive reactance XC always act as a short circuit. Okay, so now the equivalent resistance will be for this circuit will be equals to what? 1 ohm plus these two are in parallel, so it will be 4 into 4 plus 4 ohm and plus this 2 pi. Since this whole combination and these three are in series, so plus 2 pi, so it will be equals to 1 plus 4 16 over 4 8 plus 2, so it will be equals to 8 to the 16, so it will be 5 ohm. Okay, since the resistance in this circuit is 5 ohm, so using Ohm's law, from Ohm's law, V equals to IR. So current in this circuit will be V over R, and V is what? 220 volt. So 220 over R is 5. So solving it, we get current as 44 ampere. Okay. So the correct answer is option C, that is 44 ampere. Now next question 113. Electromagnetic radiation of intensity 0.6 Weber per meter square is falling on a black surface. The radiation pressure on the surface is okay. So we are given with the intensity of the electromagnetic radiation as 0.6 Weber per meter square. This is the intensity given as in the question, okay? And we have to find the radiation pressure. So the formula for radiation pressure is what? Intensity over speed of light. Pressure is intensity over speed of light. So it will be equals to intensity is 0.06. 0.6 over speed of light is what? 3 into 10 to the power 8 meter per second. So solving it, we get radiation pressure as 2 into 10 to the power minus 9 N over meter square. Okay, so the correct answer is option A. Now next question, 114. Radiations of wavelength 400 nanometer incidence of a photosensitive material of work function 2.2 electron volt. The stopping potential is nearly. Okay, so this question is from the chapter of dual nature of radiation and matter. Basically, it is from the topic of photoelectric phenomena. Okay, radiation and matter. We all know the photoelectric phenomena, that is the, let us say the radiations means light having wavelength lambda. Let us say photons are incident on a metal surface, and from this metal surface the electrons are ejecting, and these electrons are called the photoelectrons. Okay, so the radiations, we are given the radiation of wavelength 400 nanometer, and the work function is given as 2.2 electron volt. Okay, we have to find the stopping potential. First of all, we will find the energy of the incident photon. So energy of incident photon, there is a direct formula for this, that is 1240 over lambda, and this lambda should be in the terms of nanometer. Okay, so this will be 1240 over 400 nanometers. So it will be 3.1 electron volt. Let us say this is equation number 1. And we know that for the photoelectric phenomena, the equation is given as the final kinetic energy, it is equals to the initial kinetic energy minus the work function phi. And this initial kinetic energy means E can be written as hc over lambda. Okay. So now according to question, we have to find the stopping potential V. Okay, so first of all, we have to find the kinetic energy for this to find the stopping potential. So this kinetic energy will be equals to E minus phi. E is what? 3.1 electron volt minus phi, and the work function is given as 2.2 electron volt. So 3.1 minus 2.2, it will be equals to 0.9 electron volt. So the potential means the stopping potential will be V is equals to this. Since kinetic energy is given as 0.9 electron volt, na? So the stopping potential will be this 0.9 electron volt over E. So E cancels. So we get stopping potential as 0.9 volt. This is our final answer. Okay. So among these 4 options, the option A, that is 0.9, is the correct answer. Now, next question, 115. In a hypothetical Bohr hydrogen atom, if the mass of the electron is doubled, then the energy of the electron in the first orbit. Okay, so this is from the, we have to find the energy. Okay, so this is from the chapter of atoms and nuclei. Atoms and nuclei. We are given that if the mass of the electron is double, then we have to find the energy of that electron in the first orbit. Okay. First of all, student, we know the basic formula for the energy of electron. That is for an hydrogen atom, we know the formula, general formula is minus 13.6 over n square into electron volt. This is very common formula. And it is asking for the first orbit. For first orbit means n is equals to 1. So if we put n equals to 1 here, we get energy for the first orbit is minus 13.6 electron volt. Okay. And the general formula for the hydrogen-like atoms is equal, for energy is equals to minus 2 pi m e raised to the power 4 Z square over N square into H square. Okay, so from this we see that this energy is directly proportional to what? Mass for the hydrogen like atoms, na? Hydrogen like atoms, the energy formula is given as this. And from this, we see that this energy is directly proportional to mass. And in this question, the mass of the electron is doubled. Okay. So if the mass of the electron is doubled for n equals to 1, so we can write energy is 2 into minus 2 pi m e raised to the power 4 z square over n square into h square, as the mass is doubled according to question. So it will be equals to, even as in the first orbit, the 2 into, and this is equals to what? Minus 13.6 electron volt. So 2 into minus of 13.6 electron volt. So this energy will be equals to minus 27.2 electron volt. This is our final answer. Okay. So the correct option is option A. Now next question 116. The half-life period of element X is same as the mean lifetime of element Y. Assuming initially X and Y have same number of atoms, then okay. This is from the chapter of nuclei. Okay, we are given the half-life of element X and it is same as the mean lifetime of the element Y. Means half lifetime of X equals to mean lifetime of Y. Okay, mean life of Y. So we know that the general formula for half-life is, half-life formula is given as T half is equals to what? ln2 over lambda. This is the very general formula for it. And mean lifetime formula is, mean life formula is given as T is equals to 1 over lambda. Okay. So according to question, the T half means half-life of X equals to this T of Y. So now solving it, we get ln2 of lambda of X equals to 1 over lambda of Y. So from this ln2 is what? 0.693. So 0.639, sorry, not 93, 0.6393. 0.6393 into lambda y equals to lambda x. It means this lambda y is greater than the lambda x. So higher is the decay constant, higher is the rate of the decay. So here y will decay faster than x. Okay. So among these four options, option C is the correct answer. That is y decays faster than x. Okay. Now next question 117. Heavy water is used as a moderator in nuclear reactor because, okay, this is again from the chapter of the nuclei. Okay, so it is asking about the heavy water. So chemically heavy water, it is written as what? D2O. We write the heavy water formula as D2O, and this is also called deuterium oxide. We also call this heavy water means D2O as deuterium oxide. Okay, and it acts as a moderator in a nuclear reaction because it slows down the neutrons produced during the fission process. Okay, so heavy water is an excellent moderator. It is an excellent moderator because it can work at higher temperature and has low absorption cross section for neutrons. So from this, the option D is the correct answer. That is, it slows down the fast moving neutrons um, uh, because of that the nuclear fission process reaction. Okay, nuclear fission process reaction. Thus, it acts as a moderator. Got it? Now, next question 118. Photodiodes are mostly operated in reverse bias condition because, so this question is from the chapter of semiconductor and we have to choose the correct answer from among these four options. So the question is generally for the photodiodes and in reverse bias condition. So photodiode is what? It is a device which acts in a reverse, which is a basically reverse bias, and it produces current when the light falls on it. Okay, photodiode acts when the light falls on it, and when photodiode is reverse bias, the width of the depletion layer, let us say this is P and this is PN junction, and this is the depletion layer. So in reverse bias for photodiode, the width of the depletion layer increases and a small reverse current flows through diodes. Okay, so when the light falls on this PN junction diode, electron hole pairs are generated in big number, and these charge carriers can easily cross the barriers. Okay, due to reverse bias and broad depletion layer, photocurrent is significant in reverse bias even from the fractional in minority carriers. Okay, so from this we can say that fractional charge in minority carrier produces highest reverse current in case of reverse bias conditions for the photodiodes. Okay, now next question 119. Which of the following statement true about LEDs, light emitting diodes? And this is again from the chapter of semiconductors. LED are what? LED are light emitting diodes. So it is connected in always in the forward bias condition. Okay. Light emitting diodes are always connected in forward bias conditions. And the bandwidth of the light is always 10 to 15 nanometer. No warm up time is required for light emitting diodes to start. Okay, it requires very low voltage to operate, and it can switch on and off very quickly because it requires very low energy uh, for the excitation and rapidly release this energy. So the option D is the correct answer, that is fast on and off switching. Okay, now next question 120. An amplitude modulated wave is represented by CMT equals to 10, 1 plus 0.6 sine 1250 t sine 10 to the power 8 t. Then we have to find the modulation index. So this question is from the chapter of communication system. So we are given the amplitude modulated wave as CMT is what? 10, 1 plus 0.6 sine 1250 t into sine 10 to the power 8 t. Okay, and if we compare this with the standard wave equation, comparing it with the standard wave equation, what is standard wave equation for the amplitude modulation? It is AC 1 plus AM over AC sine omega mt into sine omega ct. This is the standard wave equation for the amplitude modulation, where this AC is what? Amplitude of the carrier wave, and AM is what? This is amplitude of the modulating wave. Okay, modulating wave. AC is of the amplitude of the carrier wave, and AM is the amplitude of the modulating wave. Okay, so the modulation index M, it is always AM over AC. So it will be AM over AC. AM is what? 0.6 and AC is what? 10. So AM over AC, it will be equals to 0.6 over 10 means 0.6 into 10 to the power minus 1. Okay, so from this option D, not option D, it is 0.6 na. So AM over AC means 0.6 over 10 means 0.6. It will be equals to 0.06. So 0.06 is the correct answer. Okay.